This video is about measuring segments. By the end of this video, you should be able to find the coordinate of a point, find the length of a segment, use the segment addition postulate, and define midpoint and segment bisector. The important vocabulary is number line, coordinate, distance, congruent, midpoint, and segment bisector. The word congruent is especially important. First, a number line. A number line is a line on which numbers are marked at intervals. This is a number line because there are numbers on this line. A coordinate is the number where a point is. So the coordinate of point S is -4. The coordinate of point U is 10. The coordinate is the number where the point is. Distance. The distance is the absolute value of the difference, subtraction, between two coordinates. So, for example, what is the distance of ST? Well, the coordinate of S is -4, and the coordinate of T is 8. So the distance, ST, is equal to the absolute value of -4 minus 8. Now, -4 minus 8 is -12. And the absolute value of -12 is +12. Distance is always positive. Another example. What is the distance of TV? Well, T, the coordinate of T is 8, and the coordinate of V is 14. So TV is the absolute value of the coordinate of T minus the coordinate of V. Oops. 8 minus 14 is -6, and the absolute value of -6 is 6. So the distance of segment TV is 6. Now, ST with a line on the top is a segment, senbun. ST with no line on the top is a length, nagasa or kyori. Okay, don't get these confused. The segment addition postulate says that if 3 points are collinear on the same line, then this distance AB plus this distance BC is equal to the distance between A and C. So for example, let's use the segment addition postulate. AB is 2, and AC is 7. How long is BC? Well, it will be 7 minus 2, which is 5. That's using the segment addition postulate. Here is another example. What is the value of x? Well, from the segment addition postulate, I know that AB plus BC equals AC, or AB plus BC equals AC. Now let me substitute. AB is x plus BC is x plus 3. AC is 11. Now, the first thing I will do is combine like terms. Here is an x, and here is an x. I have two x's. Plus 3 equals 11. Now I want to get x by itself. Right now it is being multiplied by 2 and added by 3. And the easiest way to solve this is by getting rid of this minus 3 first. The opposite of plus 3 is minus 3. So I subtract 3 from both sides, and I get 2x equals 11 minus 3 is 8. Now, x is being multiplied by 2. What is the opposite of multiply by 2? It is divide by 2. So x equals 4. I can plug that in, and I get 4, and 4 plus 3 is 7, and 4 plus 7 is 11, which is correct. We can also use the segment addition postulate to find lengths on a diagram. So first, I will find this length. I know that this length is 7, and this length is 2. And because these angles are all perpendicular, I know that 2 plus this length equals 7. So this must be 5, because 2 plus 5 equals 7. Similarly, I know that 2 plus 4 equals this length. So 2 plus 4 is 6, and that is this length. Next, congruent segments. Congruent means same size and same shape. Okay? Segments that have the same length are said to be congruent. In this picture, segment AB and segment CD are congruent. Okay, now here's a common error. Do not say that two segments are equal. Segment AB and segment CD are not equal. They are congruent. Next, the notation we use on drawings, these mean congruent. These little marks mean congruent, which means that R is in the middle of the segment. Okay, so we call R the midpoint. The midpoint. The midpoint is the point in the middle of a segment. Next, a segment bisector. A segment bisector is a line that divides a segment into two congruent parts. Okay, so line RT bisects segment QS. This video was about measuring segments. Thank you for watching.